Hello everyone, this is Bukya Krishna, rule number 20951A2130, branch Aeronautical Engineering, IARE Dunnigal. So today I want to discuss about the topic Introduction to fins, types and advantages. Introduction. Fins are generally used to enhance the heat transfer from a given surface. Addition of fins can increase the heat transfer from the surface by several folds. In many engineering situations, machines are often sought to improve heat dissipation from a surface to its surrounding. Whenever the available surface is found inadequate transfer the required quantity of heat with available temperature drop and convective heat transfer coefficient. Extended surfaces or fins are used. By increasing the surface area in contact with air or providing fins by increasing the heat transfer coefficient the surface by increasing the temperature difference between hot and cold bodies, so we can observe that fins are generally used to enhance heat transfer from a given surface. They can increase the heat transfer from surface to by several folds. The working principle: in many engineering applications large quantities of heat have to be dissipated from small areas. Generally, the fins increases the effective area of the surface, thereby increasing the heat transfer by convection. In other words, the shape of the fins must be optimized such that the heat transfer density is maximized when the space and the materials used for the finned surfaces are constraints. Methods to increase heat transfer rate: by increasing the surface area in contact with the air or providing fins, by increasing the heat transfer coefficient for the surface, by increasing the temperature of the hot surface, or by increasing the temperature difference between hot and cold bodies. So if we want to increase the heat transfer rate, we can increase the surface area in contact with air or providing fins. So generally the fins are very useful to increase the heat transfer rate. Types of design: the fins are designed and manufactured in many shapes and forms. So we can design the fins in various shapes and forms. They are manufactured in different geometries depending upon the practical application. So by observing the application, we can mold to different shapes and forms. The ribs attached along the length of a tubes are called longitudinal fins. The concentric annular disc around a tube are termed as circular or annular fins. Pin fins are spines or rods protruding from a surface. Types of fins. So here I discussed about four fins. First one is straight fin of uniform cross section, and straight fins of non-uniform cross section, and annular fin and pin fin. These are the four types. Straight fins. A straight fin is any extended surface that is attached to plane wall. It may be uniform cross section area or its cross section area varies with the distance into from the wall. So here is a picture we can see that is called straight fins. Next one is annular fins. An annular fin is one that is circumferentially attached to the cylinder and its cross section varies with the radius from the wall of the cylinder. So here is a picture. It describes annular fins. The next one is trapezoidal fins. Trapezoidal fins. Heat transfer by convection between a surface and the fluid surrounding can be increased by attaching to the surface thin metallic strips. So this is called the trapezoidal fins. So the advantages of these fins are: by using the fins, heat transfer rate can be increased without any preventive maintenance. It is the cheapest way for increasing the heat transferring rate from the hot bodies. So these are the advantages of by using the fins. Heat transfer rate can be increased, and it is the cheapest way for increasing the heat transfer rate from the hot bodies. Applications. Common applications of film surfaces are with cooling of electronics components, condensers and economizers of thermal power plants, radiators for automobiles, dry type cooling towers, air cooled cylinders of compressors, IC engines, evaporators and condensers of refrigeration and air conditioning system, electric motor and transformers. Results and discussion. So I came with the conclusion, that is heat transfer performance. The heat transfer performance of the heat exchanger was evaluated in terms of dimensionless parameter Nusselt number. The main purpose was to test the effects of geometric, those are tube arrangement, fin shape and tube inclination angle, and flow parameters on the heat transfer performance of compact flat tube and fin heat exchanger. Conclusion. From this study, it was found that the rectangular fin has the highest heat transfer performance compared to the wavy and plane fin, where wavy fin is higher than plane fin. Rectangular fin produces the highest heat transfer performances due to the interruption done by the staggered surfaces to the flow and temperature boundary layers along the flow orientation. The hydraulic performance has a similar trend where rectangular has the highest pressure drop compared to the wavy and plane fin. This is due to the interruption that the wavy and rectangular fin geometry does to the flow of air. The pressure drop of plane fin is low compared to complex design of wavy and rectangular fin. Wavy and rectangular fin, despite having higher heat transfer performance, they have a greater drawback in higher pressure drop. On the other hand, rectangular fin is suited for any application which prioritizes thermal performance over hydraulic performance or efficiency. So this is all about the types of fins and advantages. Thank you.